Your body is a master of repair. You get a bruise, your cells fix it. You break a bone, your body knits it back together. But for 1 in 2 million people, the repair protocol has a fatal logic error. Imagine a toddler tripping in the park. A minor bump, a purple bruise. For you, it's a week of swelling and then it's gone. But for those with the Stoneman Glitch, that bruise is a biological starting gun. Deep inside the muscle, the immune system rushes to the site of the injury. But instead of repairing soft tissue, it triggers a catastrophic transformation. It begins to lay down hydroxyapatite, the same material found in your teeth and bones. By the time the swelling goes down, the muscle is gone. In its place sits a shard of solid, ivory-hard bone. This is fibrodysplasia ossificans progressiva, a condition that literally turns the human body into a statue. The strangest part: this glitch is hidden in plain sight from the day you are born. There is one specific software error doctors look for in newborns to predict the future. If a baby is born with their big toes shortened and curved inward, a condition called hallux valgus, it's a red alert. At birth, the child looks perfect. They move, they play, they grow. But beneath the surface, a genetic bridge is stuck in the open position, waiting for the first major flare-up to flood the muscles with bone. It is a biological time bomb with no countdown. Most families don't know the truth until the first flare-up happens, usually before the age of 10, often triggered by something as simple as a routine childhood vaccination or a fall from a bicycle. And once the bone starts to grow, there is no way to take it back. To understand why the body begins the self-petrification, we have to look at the software code itself. Inside every cell of your body is a gene called ACVR1. Think of it as a biological gatekeeper. Under normal conditions, this gene acts like a bridge that is strictly guarded. It is only supposed to open during fetal development to build your initial skeleton, or in rare cases, to repair a fracture. Once the job is done, the bridge clicks shut. But in the Stoneman Glitch, a single genetic mutation, a swap of just one letter in the DNA sequence, changes everything. The bridge is now jammed in the open position. The sensor that is supposed to say stop building bone is broken. Now, every time the body experiences even minor inflammation, the gate swings wide, and bone-building proteins flood into places they were never meant to be. So, what does this genetic bridge failure look like in the real world? It starts with a flare-up. These are unpredictable, episodic swellings that can appear overnight on the neck, back, or shoulders. To a doctor who hasn't seen FOP before, these look like aggressive tumors. They are red, hot to the touch, and incredibly painful. And here is where the tragedy of the Stoneman Glitch truly lies. In a normal patient, a doctor would perform a biopsy or a surgery to remove the growth. But in an FOP patient, the scalpel is a death sentence for mobility. Every cut, every needle, and every surgical intervention is seen by the body as a massive injury. The broken ACVR1 bridge swings wide, and the body's repair mechanism goes into overdrive. Instead of healing the surgical wound, the body replaces the entire area with new, solid bone. Doctors who have tried to cut away the extra bone have watched in horror as the bone grew back even thicker and faster than before, permanently fusing the joint in place. In the world of FOP, the only way to win is to never touch the wound. As the years pass and the flare UPS continue, the body begins to develop what scientists call a second skeleton. This isn't a neat, organized structure. It is a chaotic web of bone bridges that crawl across the back, the chest, and the neck. Eventually, these bridges reach the ribs. The Stoneman Glitch begins to fuse the rib cage into a solid, unmoving cage of ivory. This is the hidden danger of FOP. When the ribs can no longer expand, breathing becomes shallow. The lungs are trapped. But perhaps the most isolating stage is the locked jaw. If a flare-up occurs near the jaw joint, the bone can fuse the mouth shut permanently. This leaves the patient unable to eat solid food or even speak clearly, literally locked inside their own skull. It is a slow-motion transformation, a bridge-by-bridge construction of a living, breathing statue. To understand the true weight of this glitch, we have to look at the man who gave his life to solve it. Harry Eastlack. Harry's transformation began when he was just 5 years old, after a simple leg fracture. By the time he reached his teenage years, the bone bridges had fused his spine, his neck, and his hips. He wasn't just a patient, he was a pioneer. Knowing there was no cure in his lifetime, Harry made a final, heroic request. He asked that upon his death, his body be donated to science. He wanted doctors to study the ivory cage that had imprisoned him, so that one day, no other child would have to endure it. Today, Harry's skeleton stands in a glass case in Philadelphia, a haunting masterpiece of biological error. Every bridge of bone you see on his frame is a physical record of a flare-up, a history of his body's failed attempts to heal. Because of Harry, we finally identified the ACVR1 glitch. He remains the most important teacher in the history of the human lab. For decades, the Stoneman Glitch was an unstoppable force. But we are no longer in the dark ages of medicine. We have entered the era of the software patch. Scientists have developed a new class of drugs designed to do what the DNA cannot: force the bridge to close. One of the most significant breakthroughs is a drug called palazeridine. Think of this medicine as a digital override. It targets the broken ACVR1 sensor and sends a counter signal, telling the cells to ignore the build bone command. In clinical trials, this patch has shown the ability to reduce new bone growth by over 60%. We are moved from a world where FOP was a life sentence of petrification, to a world where we can finally tell the body to stop. It is the first time in human history that we have successfully hacked the repair protocol to save the patient from their own healing process. But the Stoneman Glitch is more than just a medical curiosity. It is a mirror held up to the human condition. It reminds us that our greatest strength, our body's tireless drive to repair itself, is governed by a code so delicate that a single letter's change can turn a healer into a jailer. Today, the children born with FOP face a different future than Harry Eastlack did. They are the first generation in history who may never know the permanent lock. We are no longer just victims of our biology, we are becoming its architects. Harry Eastlack gave his body so that we could find the key. Now, it's up to us to finish the work. If you believe that the secrets of the human code are worth uncovering, join us. Subscribe to the Human Lab, and help us tell the stories that define what it means to be human. I'm Marcus. And the lab is always open.